which is going to be about construction category 3. But now I'm going to introduce Dennis Farmer. He's going to introduce himself. But Dennis, as you know, was in the Farm Council, and he's going to tell us all about
well, thanks everyone for coming. So I'm going to be showing some slides on R, and if the opportunity permits, also maybe getting into R on my laptop and showing you the environment a little bit. So I'll be switching back and forth. So with technology, there's lots of opportunities for stuff to break. So that's good. It'll add an element of suspense for me at least. But today I'm going to talk just briefly. Demonstrate some of the things that R can do for people who are considering transitioning from another data analysis tool to R. Also, talk a little bit about some of the resources that are out there to help make that transition, and maybe provide some tips on things that might help or ways to think about learning R. That last part might be a bit opinionated. It's my experiences or experiences of people that I've talked to. There might be some other views, but it's just some ideas for how to get started with R. Okay, so the first question, what is R? As a lot of people probably know, R is an open source statistical analysis software tool. It's free. Anybody can download it. There's no charge. It's open source, meaning that you can look at the source code, you can contribute to R. You can even, in some cases, if you read their general purpose license, you can even bring R into your own products, use it, modify it, and redistribute it. And on their website, they have information about the things you need to follow for their own license. But one of the nice things about R is that it provides a single environment for a lot of like the whole workflow that you might have in analyzing and exploring it, and even presenting data. It's a good tool for bringing in your data and for cleaning it up or transforming it. It's a good tool for exploring it. It's a very powerful tool for doing different forms of statistical analysis and modeling. And also, it's a very good tool for data visualization. So you can use it, you can use the same environment to do lots of graphs to look at the data yourself. And in a lot of cases, if you're willing to put in a little bit extra code, you can get some really nice publication quality visualizations of your data that you can share. It's commonly seen as an alternative to SAS, SPSS data, Excel. There's lots of different software that it can replace. It's also, Python is another open source alternative that can do data analysis. But R is becoming increasingly popular source because, once again, it's free. So someone mentioned licensing, no licensing issues. It's powerful, it's a programming language written specifically to do statistical analysis. So it has a lot of power to do lots of different things. It's extendable, meaning that people are, because it's open source and because it has a large community, people are frequently writing what's called packages, which are sort of modules or things that you can bring in that allow you to do different things with R. So I know we've had some cases with some of our software where we have a data scientist group in Metro Transit. I know when they've been looking at some of the different software for statistical analysis, one of the things that they like about R is that sometimes they would find that they would want to do a new form of modeling, and under some kinds of proprietary software, they would have to buy more or extend it. Whereas with R, frequently you will find that somebody has written a package that allows for a certain kind of modeling that extends the capabilities, and you can download that for free. Another nice thing that we began to notice is that a lot of students are using R. It's become a popular tool in a lot of computer labs because of its power, also because it's free. So a lot of new employees that we're getting, a lot of new data analysts that we're getting are increasingly using R. When I was in school, we used a lot of SPSS, and then you would often go into work for somebody who didn't have SPSS, so you have to learn something new. Finding out that a lot of students now are coming out of school learning R. The nice thing about it too is that because you're writing code, you are actually, when you do analysis, by writing the code, you're actually creating documentation for your analysis. So you're creating reproducible code. You can go back later and see what you did and trace it. You can show it to other of people. I've heard a lot of people say that when you do a project, you always want to make sure that somebody down the line will be able to retrace your steps, and then that same person will often commonly point out that that person that needs to retrace your steps is you in the future. So it's good for that. It saves me a lot of time. So the cons are that it has a steep learning curve. I think mainly because it's a programming language, and it's a programming language that a lot of people, maybe it's their first programming language. It's a lot of console-based programming. There's not a lot of pointing and clicking. So you do have to learn the language. You do have to learn some of the little tricks of R. There is a steep learning curve, but it is surmountable, and it pays off. It's a pretty old language, and one thing that I read that in some cases it can be slow with larger data sets because it relies upon physical memory. When you read in data, it often brings it into the physical memory. I've heard that's not as much of an issue now as memories on computers get bigger. Also, as people have contributed more, people are finding ways around that. So there are some packages that are helping to deal with that problem. But using it out of the box, it may not be as fast with SAS for some large data sets. But we've used it for larger data sets too, and we found some of those, some ways to speed it up. There's lots of packages, which is good. The quality, or more specifically, the documentation that you get with packages, it does vary. There are protocols, but sometimes you'll find a package and it's meticulously documented, and sometimes you might get a package and it's not documented as well. But that package, it was free. So, and also one of the things some people point out is that there's lots of different ways of doing things in R, which some people find confusing. Some purists might not like as much. Sometimes you might find multiple packages that do similar things. But I think the pros outweigh the cons, in fact. So I want to make one distinction because I know there's two products that are commonly used, and I know in our agency sometimes people kind of get them mixed up, but two things people often use in R. There's R, which is the base statistical software, which you download for free. And then there's another product called RStudio, which you can download. There's a free version that you can download on your desktop. The company also offers a version that you can pay for where you get support, and they also have enterprise versions which cost money. But there is a desktop version of RStudio which is free. And RStudio is basically, it's an integrated development environment that you can run, I guess, on top of R, and it makes it a little bit easier. It gives you multiple screens. It allows you to navigate files a little bit easier. It just makes, for a lot of people, the experience of using R easier. And if we have time, I'll try and show you what the two different interfaces look like. It also can expand R's capabilities quite a bit. So just going to go a little bit into R's capabilities, just to kind of give you a sense of what R can do. One thing that I found in using R that is a plus is that it reads in different sources of data pretty easily. It's really good at reading in tab-delimited files, text files. Sometimes you can just quickly read in files if they're very simple or there aren't any hitches, just using some simple code, some default code. So for instance, on my computer I had 3 different files that I had. They were both downloaded from Metropolitan Council Data Download, which might surprise me that if I didn't advertise that. We have a really good interface where you can download a whole bunch of data. So this is ACS data on the average commuting time from the 2011 to 2015 ACS in minutes by city. So I'll be kind of going over some of the things I've done with this data. So when we download it from our website, you get in this really nice, neat, tidy CSV file. And in order to read it in, all I had to do was test the code that I used, and I read it very cleanly. Sometimes if you have data that's a little trickier, there's a whole other string of arguments you can do to tell it how to treat the data. So you also can specialize, and you can specify certain things. So, but it's often easy just to read data in with one line of code. R also has a library that you can download that allows you to bring in Excel. So I'm able to upload an Excel version of it. Also, for SAS users, there's a library that helps you read in SAS files. There's a little description by it which says experimental. I'm not sure what that means, but it's always worked for me. In fact, I'm able to read this on a computer. I don't have SAS on that laptop, but I'm still able to bring in a SAS file and read it. So there's lots of different ways, and you can explore. There's lots of different packages for certain kinds of files. So I think it reads in data in a lot of different formats, even other proprietary softwares. It's really handy for summarizing data. So this is an example of, in that same data set, what I've done a little bit of cleaning. I've taken the data set and I've just told it, just give me year 2015. I'm looking here at community designations. In addition to cities, the Metropolitan Council groups different communities by their development stage. So we have an urban center, we have suburban edges, emerging suburban edges, rural. So in this case, I've told it, just get me 2015 data, and then remove all cities that don't fall completely within the council's jurisdiction. And so now I've got a data set, and so in order to get the mean, all I have to do is just tell it, give me the mean of this data set, this column. So one line of code, and I'm finding out that the average in 2015, 2011 through 2015, the average commuting time was about 25.8 minutes. Standard deviation, simple, you just type in this code, standard deviation, SB, and I get the standard deviation. So for a lot of things, we get a lot of statistics. It's really parsimonious code. Yes, hi.
Not a question of the concept. Did you be able to share your presentation from it?
Yeah.
Instead of trying to copy down the notes,
yeah, we'll make a copy available, and I can also share some of a bigger file that has the specific code inside. So, yeah, definitely. You can also do it by grouping. So this is kind of the same thing, but I've just done a little bit where I pulled it group by community designation. So these are summary statistics, not just for the whole region, but this is for the different community designations. So, and this probably isn't surprising information. Central areas have, on average, lower commuting times. So it's nice. You can get these nice tables. You can get summary statistics by different groups if you have categorical data. You can do, and of course, this isn't an exhaustive demonstration, but this is some of the things that you can do, and to show how you can do a lot of it with some pretty simple code. This is an instance. One of the things I was looking at is that the suburban edge is about 2 minutes slower, or the commutes are about 2 minutes longer than urban areas. So if I wanted to do a t-test to see if that difference is statistically significant, once I get my data cleaned up, I can just tell it, look at the data and do a t-test, comparing with the null hypothesis of 22 minutes, which was the urban center. And it gives you a readout basically, which is basically telling you got your confidence intervals, what the mean of what your alternate hypothesis. It even tells you what your alternative hypothesis was, and it basically shows that it's statistically significant. You can get a confidence interval. So it gives you it's kind of a nice quick way to do some of this testing. I think R is really good for doing certain kinds of statistical modeling, like regression model. This would be the code if I wanted to do a linear model looking at the commute time. This is the column name by community designation, and this is telling it to look at the year 2015. So you can get, you can do all kinds of generalized linear models pretty simply in R-based packages. And there's also some extensions if you want to do things like multinomial logistic regression modeling, if you want to do things like Bayesian model averages, that kind of thing. There's also lots of packages. You can do a lot with very simple code. In fact, one cautionary note, you can do a lot of stuff in R that you don't really know what you're doing. So it's always good to kind of check into the assumptions. But I suppose if you've gone to work one day saying, I want to do Bayesian model averaging, you're probably thinking about you're going to meet all the assumptions. But that's just one caution. You can do lots of stuff in R, and R doesn't necessarily check to see if you're meeting the assumptions of a particular model. So, but it does have a lot of really good diagnostic plots that you can call up that will show you if you're meeting a lot of the assumptions. But that's the logistic regression model. This is and then it would give me a printout. Basically, this is a very interesting model. It's just treating the community designation as a bunch of dummy variables. But it does give me the readout. So in this case, I think the reference level is agriculture. So basically, it's giving me the estimate on average urban areas, 3.36 fewer minutes, all things all things being equal, then agricultural, it gives you the standard error, it gives you the t-score. It'll give you the R squared and the adjustment R squared, so you can look at the fit of the model, all pretty quickly, all pretty simply. I think R is really good for data visualization. So this is that same data set, and I've just asked for a simple bar graph so that you kind of get a visual of how commute times go down across the different community designations. This is a pretty simple plot. And, you know, it didn't take a whole lot of code to write. I had to customize a few things, but, you know, probably pretty close to being ready to share in a document. This is another line plot where I've just taken for all the years I've done how the average commute time has increased or decreased for the different community designations. So you can do, you know, you can do histograms, you can do line plots, scatter plots, anything you can basically, any visualization you can think of is either in our base package or somebody has written a package that you can extend it. So another nice thing I like with R is that it's become increasingly easy to make interactive plots. With R, there's a lot of tools out there to do interactive plots, like you have Tableau, you have D3, some cost money, some require a lot of coding. R has a lot of packages where you can take a lot of the graphs that you've already made and you can turn them into interactive charts that you could either export to an HTML to share with people, or you can just use yourself to explore. So this is that same chart. I've just basically wrapped the same code into using a package called Plotly, and I'm able to make an interactive chart so that I could, if I want to, I could hover over things to get specific values. If I realize, you know, I'm mainly interested in commuting in urban areas, I can turn off different layers so that now I'm just looking at the suburbs in the urban area. If I'm looking at these and I realize that there are big gaps because I'm going from the 2000 decennial census data to, I think, 2007, where we have ACS data. So I only want to look at a subset. I can zoom in. I think this will work. And you can just focus in on a certain area. So it's kind of nice with you. I'm often finding that when I'm looking at data, I want to look at a chart, but the chart just doesn't tell me what I want. Instead of I want to focus in on something. So instead of making a series of charts, sometimes I'll just kind of throw up a simple interactive chart and I can poke around in it a little bit. So that's just, oh, and one more thing too, that going back to that reproducibility, one thing that's nice about R is, in addition to having a script where you can see what you did, you can also use R Markdown. You can write your code in this thing called R Markdown, which are these files which do a really nice job of weeding narrative text, code, graphics into one document that's really readable. So, for instance, and a lot of times, you know, when you're writing scripts in R, if you wanted to have a comment, and, you know, normally in just a script you would, you know, if this was your function, you know, you'd have a hash mark and you'd write a comment here, average. You know, you'd have all these documents that you could put in your script so R knows not to run it, and you still have these notes to yourself. But one of the nice things about R Markdown are you can create these documents that allow you to write code and also include really readable text. You can put in graphics, you can put in pictures or images or tables. See if I can have this is an example, just a simple example. I took okay, this is something I did for a Coursera class I took a while back. So this is actually, when I wrote this in R, and these areas right here are actually code blocks. They're the codes that I was using. And so I write those in, and I also can type in text so that, and with a little bit of formatting, you can put in headers, you can put in subheaders, you can put in long paragraphs. So while you're writing it, you can add in longer text, which are a little bit more readable than just a comment block. You can put in bullet points. if you run graphs, if you write codes to do graphs, it'll include those, it'll print those out. You can actually, if you're talking about something and you want to show a graphic, you can do that. You can do, you know, all kinds of graphs. You can also make some nice tables too of your data so it looks a little bit nicer. So these are really nice because if you were to give this file to somebody, it's an actual program, and when they run it, if there's something wrong with the file, it'll crash. So it'll run it, and it'll also print out, you can print out a PDF, you can print out Word documents, you can print out an HTML file. So it's actually a way of documenting your work, giving it to somebody, presenting the results in a really readable format, and also giving reproducibility. So, any questions so far as I navigate between these two things? Okay.
Just one question.
Yeah.
My experience with R is that it can really shine if I have an assembly line kind of thing. I have to generate 30 charts, and I want them to look exactly the same at y-axis, x-axis. I want it blue, I want it. So have you done something like that?
Yeah, there have been lots of instances where I've had to make a lot of charts, and one way to do it is you can just write it out to do one, and then if you have a new data set, you can just put in new parameters. Sometimes, a lot of times too, one nice thing about R is since it's a programming language, you can also do things like create loops, and so you can also if you have something you need to do over and over again, you can go the route of just typing, just replacing one line of code, say to look at a different variable or to look at the data set. You can also just wrap it in a function and just say, for all the data sets I have, and then you just create a list of all the data sets. You can just say make a chart, and it can loop through. So yeah, it's very handy for that, especially if you kind of get in the looping. And I think I didn't have a whole lot of programming experience going into R, but one of the nice things is once I was using R, I was much more adventurous in learning how to do more as opposed to learning how to program, learning how to use R to do my day-to-day work, and then you realize, well, I could do a loop and make it easier. And so it also is kind of an encouragement to expand a little bit of your coding aspirations. Any other questions? Yes. It can be very easy. You can export them out as self-contained HTML files. So you can put them on a drive, or you can email them to people. And all they should be able to do is just take that HTML and open it with Chrome or with Internet Explorer. You can also make them outward facing so that they reference data on a server, and you can use them that way. But a lot of times too, if you just want to share them internally, you can just specify that it's self-contained so that all the data is actually inside the HTML file, and you just send it to somebody and they can use it. Bridge has done that. I've done that for Bridge a couple of times, so it can be quite easy, yeah. So another thing, so you're using R, you're all using R now, and you're like, it's great. Some of you may be using Esri, and you think, well, can R do spatial analysis? It can, and it can do pretty much anything that Esri can do. That also has a learning curve, perhaps a steeper learning curve. But one of the nice things about doing R for spatial analysis is I know in my own job I found that I'll do a lot of data manipulation or recoding variables, or a lot of analysis on the data associated with a spatial data file. Stuff that I don't necessarily know how to do using Python and Esri, or that's a little too complicated for the field calculator. So I used to find myself doing changing a lot of the data sets associated with spatial data in R, and then bringing it into ArcMap whenever I would have to do some kind of spatial analysis, an overlay or a buffer. So finally, I started looking into how you can actually do some of that in R, so you can keep it all in one script and not have to go back and forth. And you can do it. The nice thing is that you can use a lot of R statistical modeling abilities on spatial data. Again, you have that reproducibility. You're not pointing and clicking, so you can reproduce a lot of what you're doing. one of the disadvantages is that you have to learn how to do it. Sometimes that point and click is actually kind of nice to have. It's a little bit easier to do. There's lots of different packages for R that if you want to do spatial data, so you kind of have to have, it's helpful to have a little bit of a map, what does what. Map. That was unintentional. No, it was unintentional, seriously. Also, one of the things I like about ArcMap is, you know, as you're doing data, if you're doing data in a map document, you can go in and you can kind of look at the data and click on polygons and see what's changed and what it looks like. And it's a little trickier to do in R, although there are ways to do that. So I did have, along with this presentation, I have included a link to another presentation, which will be available when we make this available, which has some nice slides about if you're an Esri user, what does I do? This is how I do it in ArcMap. How do I do it in R? So, for instance, this has, you're doing intersect. This is the library, and that's the function you want to look at. If you're doing buffers, there's a package called gbuffer, and this is the function you want to look at. So that'll be available. No, that's later. All right. And then again, this is just mainly for reference for people to look at later. These are also some of the packages. This is probably scraping the surface, but some of the different packages and what they do. So in addition to doing spatial analysis, you can, just like you can plot a graph, you can plot a map. And you can specify what the different fields are. So for instance, in this case, this is a map that I made of just using a state file that has the population for transportation analysis zones, which at the Metropolitan Council, we often divide up, forecast the population into these small little chunks that our transportation planners use when they look at how people make trips. So they're usually, in urban areas, they're usually pretty small. They follow the highway network. So it's basically little pieces of cities. So there's sub-area forecasted zones. And so this is a map I made in R using a data set. It's just a chloroplast map that you might make in Esri where deeper shades mean more population. So it's nice that you can kind of show this to somebody, but it's unlike ArcMap, it's static. You can't export. But there is something, there is a package in R that allows you to make leaflet maps. Are folks familiar with what a leaflet map is? A couple? So a leaflet map is, it's an open source JavaScript library that allows you to make interactive web-based maps. A lot of publications and websites use it. I think the New York Times, the Washington Post uses it. And it's a way to make maps, and you can either share them on a server, or again, like with the other interactive charts, you can turn them into an HTML map, and you can just send them to people as a self-contained HTML map. So here's an example. That same map I made of population density. I use the same data set, but rather than just plot it in R, I plotted it in Leaflet. There's something going on with this legend here that wasn't going on my computer at work, but the idea basically is that you can, these are interactive, so if you wanted to move around, look at a certain area, you can do that. If you want to zoom in on an area, you can do that up at the top. It gives you some widgets, so you can also click and drag. You can have pop-ups so that you can kind of explore the data a little bit more. So that tells me here what the TAZ is and what the density is. Just like with ArcMap, you can turn layers on and off. So in this case, if I was interested in what this area is right here, and the color class is getting in the way, I can turn it off and kind of zoom in. I think that's down. So, and you can also turn off the background if you just want to see without that. So this is a leaflet map, and I'm telling it as a background for the base map. I'm telling it to go to OpenStreetMap. So there are other services. I think you can also do a Google Map on them too. But these are kind of nice because you can share these with people too, and it gives them a little bit more of an opportunity to zoom around, to, you can specify what the pop-ups are. You can also share this with people who don't have ArcMap. So, you know, anybody that's got a web browser can look at these maps. So that's one way of kind of getting a little bit of that interactivity that you get from Esri out of R, and also possibly share it to a wider group, maybe even host it on your website. So that's just a brief rundown of some of the capabilities you have with R. I want to talk a little bit about some of the tips that I found getting started. One is, you know, download R. That should be self-obvious, but and there's a link here about where you can find it. So you can download R from the CRAN, which is the, I think, consortium of R. I'm not quite sure what it stands for, but basically there's a group that hosts it. And what you do is you can click this link. It'll tell you to pick a mirror or a place you want to download it. You can download it from Europe. You can download it from Berkeley. There's lots of different options. But and then it'll give you an option to download it for Windows, for Linux, or for Apple, for OS. And once you download it, it has an executable that you can put it on your computer. It's probably a good idea to talk to, if you have IS folks, it's probably a good idea to talk to IS folks. We should always do that, they're our friends. Also, if you don't have, you can download it without admin rights, but I think it may cause problems when you're downloading packages. So it's always good to have somebody download it who has admin rights. So, downloading R is pretty easy, it's pretty simple. You might want to consider downloading RStudio, and hopefully I'll have time to show what that is. But again, that makes it, I think, a little bit more intuitive, especially for people that are used to using some of the other softwares and who aren't used to the console environment. I use it. Most people I know also use RStudio. And again, there's a free version. You can get a supported version or an enterprise version for these, but it's also free to have a desktop. So there's a link there for where you can download that. Also, it's good to know to learn how to get packages. You have to download those. You can download them off of the same website where you get R. You can also, sometimes people are now contributing software to GitHub, so you can download them directly from there. It's recommended that you go through, RStudio has a nice interface where you can just pick the software, and that's highly recommended because some of these packages have dependencies. So in other words, if you want to download it, if you want it to work, you got to have this package. And before I had RStudio, I would kind of get into these labyrinths where I would download it. You'd say you need this, and so you download that, and then package B would say, well, you need C, and you can really kind of get down a rabbit hole. The new tools, if you use RStudio, or if you go into the console and you type in install packages, a lot of times it'll just install all of the dependencies for you. There's also a package called DevTools, which makes it easier to download and compile packages that you might be getting from GitHub. So useful to take some time and figure out how to learn and download those packages. This is kind of optional, but there's a statistician programmer from New Zealand. His name is Hadley Wickham, and he's created a lot of packages that are becoming very popular that kind of simplify a lot of the functions. So ggplot, the R that you download can do some graphics, but ggplot has some nice methods and routines for doing anything from simple graphs to publication ready graphs. One of the nice things about ggplot is you can type in some simple code if you just want to look at, if you just want to graph something simply, and you're not too concerned about what it looks like, but you just want to explore it or share it internally. And then it's hierarchical, so you have a simple code just to get your graph, and then you can gradually add things on as you want to maybe customize the axes, maybe you want to change the theme. In fact, it literally uses pluses, so you might have one piece of code for the simple graph, and then you would say plus, and then you would add in what you want to do with the legend. So you can really gradually build on and to the chart. You don't have to necessarily know how to make it perfect to look at it, and you can incrementally build on. It's got two packages called dplyr and tidyr, which were that code I was using to subset the data and clean up the data before we were graphing it. I use those. So these are becoming increasingly popular. I guess they're called opinionated software. It's kind of a new term to me, but I guess what that means is that it kind of forces you into doing it a certain way. So, and the trade-off is that it, in some ways, it does a lot of what you want to do and it's easier. So that's one thing to consider, is to look into some of those packages, which are becoming increasingly popular. Step 4, in my own experience trying to learn R, I think the first thing that really helped me kind of get my hands dirty was figuring out how to read data and how to get it into a data frame. I know for me, getting on a console and programming felt a little bit abstract. I just felt like I didn't know what was going on behind the scenes. But once I was able to bring in data and bring the data up and look at it and run programs and then look at the data again, just having that data set there that I could look at periodically really made the process a lot more intuitive and comprehensive for me. So I think the first thing would be to learn with just experiment or learn how to take data, whether it's an Excel file, a CSV, a text file, and read it and start looking at it, and then go from there. There's a link here with some resources on how to read different data sources. All right, so now I think learning, different people learn different ways. I think there's a couple different approaches to learning. One is that some people try, and I think some people like, is just they get the manual, they get a book, and they try and learn what R is, how to program. They try and get a deeper understanding, and then apply it to a project. And I think that works for some people. If you're not one of those people, I'm not. I have limited. Well, first of all, if you are, or even if you aren't, I've left some links here. These are some good places to learn R. The place where you download R has a lot of official documentation about R. There's a site, maybe I can bring it up here, called Try R, which is there's a few sites like this that actually allow you to. That kind of emulates R, so it'll tell you to do something. It'll say, you can add with R. Type this in, right? And then and then it's like, there, you did it. There, your first R program, you added 1 + 1. And it kind of shows you how to do that, and it kind of walks you through a tutorial, so it's not just reading in a book, you're actually typing into an interface that looks like R. You had made a pirate joke. One of the disclaimers I've read about this site is that there's lots of pirate jokes here. So if your tolerance about pirate jokes is low, you're warned. Coursera has a lot of courses in R programming. Some of them are free, or they allow you to take them for free, and they just don't allow you to get a certificate or participate in the final project. But there's a lot of R programming, a lot of Coursera classes that are free and quite good. There's a program called Swirl that actually, it's actually an R package. If you bring it up and you invoke it, it'll do a little bit of like what that Try R website did. It'll print out on the console. It'll say, do this, and you do it, and it'll say, it'll show you what happened, and it has these really encouraging messages with exclamation points out of them, like, good job, you're doing great, you'll learn this in no time, seriously. That's kind of fun, and it also is nice because you're actually typing in R. So there are a lot of interactive. Udacity and DataCamp are two other places that have some good classes. There's a book called Quick R, which a lot of people like. Another way, this is kind of more what I did, is kind of reverse that. One thing you can do too is you can say, I've got this project. Hopefully it's something that you know R is pretty good at, like maybe a regression modeling. And you say, I know what I want to do. I want to go online and I want to find examples, and I'm going to take code and I'm going to modify it. That's actually not, surprisingly, it's not a bad way to do it. In fact, for a lot of people, it actually really helps to do. You will find examples of stuff that you want to do, and it may just be changing a few different codes, and maybe you don't understand everything you're doing, but you will over time. One person who I took an R class said, if you're writing code from scratch, you're doing something wrong. So you can borrow code and modify it, and that's not too bad of a way. That's kind of how I learned. So these are places, and again, so we'll have these links. These are places where you can get information. You get information in R by typing help, and then whatever your function is, you can type in a question, type in a function. Yeah.
You showed earlier a slide that shows an Esri and then the R sort of equivalent.
Yeah.
So the things like FTSS, I know the syntax, and it's sort of the equivalent.
That's a good point. I imagine there are cheat sheets. I know that I've had luck. If you know how to do something in a particular program, often if you Google, like for instance, Excel Summit in R, you'll find a Stack Overflow, because that's how a lot of people. You're right. A lot of people ask questions by saying, "This is how I would do it in SAS." So just like that, Esri. That's a good point. I don't know of any cheat sheets, but I'm sure if you were to, I'll look now if you suggested it. I know individually though, that's often a good way to do it, is to say proc means. I want to do proc means in R. And you'll often find somebody has asked that, and they'll do an equivalent. Often on some of these very websites, Stack Overflow is a good place. Art Studio, that makes Art Studio, has a series. If you click on this link, they have a series of like one-pager cheat sheets, which are fantastic. Our Bloggers is good for. That's a good website to check into to kind of expand your capabilities. People will blog about things that they've done or that they've noticed. So if you're using R and you want to find out, keep up with you, that's a good place. Flowing Data is a good website for our data visualizations. I know my time's running out, so I'm going to do, actually what I think is the most, maybe my recommended approach would be to do a little bit of a hybrid. Maybe take 2 hours of training and get some of the basics, and then find a project, see how far you can get, and look for examples. So don't necessarily get out the manual or read the book from cover to cover, but just, there are places, and there's some links here where you can get just the very basics, a couple hours where you can get started, then pick a project, look for an example. And so don't be afraid to Google, don't be afraid to call your friends who use R. Just to say a little bit about Google and how you can pretty quickly find some things. Last week, some staff, we often share data visualizations excitedly amongst ourselves, like I'm sure a lot of you folks do. And somebody shared an example of what's called a joy plot. I don't know if people know what those are, but they're these histograms that you kind of stack next to each other so you can compare the distribution, not just like how much more something is, but what the distribution looks like. And so we had somebody shared one of those, so we were curious, well, can you do joy plots in R? And so if you, I should have had this ready. This is exciting radio, but well, somebody on GitHub posted a package which uses ggplot, but uses ggplot and allows you to make really simple joy plots. This is what they look like. So, so in about 15 minutes using that, we were able to take that same data set, which is average commute time by community designations, and create a joy plot for the different areas. And I think they're kind of neat because they show how areas do, on average, have a greater mass maybe of people or of samples that have longer plots, but they also show there's quite a bit of overlap. So if you've ever done any like clustering work and you've had to try and explain that clusters group things, but there might be similarities because you're using lots of variables, I think these are really good tools to kind of show people like clustering and how urban centers can have they have lower commute, but there are suburbs that have lower commute, so it kind of gives you an idea of the distribution. That's just an example of like the stuff you can find pretty easily. And I think also I heard a rumor that the reason why they're called joy plots is because there's an album by Joy Division that has it's an album cover that looks like that. So I've heard that's why. I don't know if that's internet apocrypha, but that's all I have. Does anybody have any questions, or do you want to see what Art Studio looks like versus R? We have to change. Okay, so I'll distract everybody by asking if there are more questions. Does anybody have any questions while we do this? Yes.
And just to explain, I was just wondering, in fact, they call it a survey class, but that's really related
Yeah. That's a really good question. Relevant too. So we had somebody. Yeah. So if you look at so if you have survey designs, surveys will have weights, and if you want, my understanding is if you want to get variability or standard error, you have to use some of the weights that people create. So if you use ACS data and you want to see what the standard error is for a block or a block group, it'll have a weight, meaning that that sample is supposed to represent a certain weight of the population. And then it also has like something like 80 other sample weights that you can use to create variability. And you can do it pretty easily in SAS. Yeah, there is a package called survey in R. And in fact, one of the ways that we were able to figure out, it's not easy because it's not an easy thing in general. But one of the ways we were able to figure out what we needed to put in that package was we looked up what we put in SAS and we looked at what we need to put in R, and between looking at those two, we were able to figure it out. That just happened a couple of weeks ago. So yeah, so it's called survey, and it'll do a lot of that for you. It's not, it's not easy, but then I suppose if you're at that level of analysis, you probably understand what it's asking you to put in. But yeah, so there is something to that. So. Yes.
With the interactive data visualization, you can zoom in and all the things around. You said you can share it with other people.
Yeah.
If they don't have all, can they still do the same manipulation or kind of exploration?
Yeah, they can. They can do it through HTML because you're actually creating an HTML and file, and I believe you're also embedding some JavaScript in there. So what it's doing is it's creating an HTML file and all these widgets, but it's doing it in a way you're not having to write that much code. It's you don't have as much flexibility, but you are you can do some things, and by writing some code, it generates a lot of that JavaScript for you. And so yeah, if you have an HTML file, if you can give it to them as an HTML file, and they can use it in a web browser. Now, if they want to create it or modify it, they would have to go into R. But if they want to, like anything I was doing right here, this computer doesn't have to have R on it, so it was just doing it through Google Chrome. So. All right. Any other questions while I? So this is R. So it's a console. Right. So and so you're typing into the console. You do have a little bit of a menu up here, and you can also create scripts or run scripts. So like right up here, I'm creating a script which I can make a text file and I can run it. If I make plots, a new window will pop up here with a plot. This is what RStudio looks like. So so this right here, this is actually the equivalent to that script I was showing. So here I'm reading a script, I'm typing in a script. I can actually hit that and it'll run it. You'll see it down here in the console. You can type in the console. This shows you all the data that you've read and all the objects you've created or any functions that you've written. So one of the nice things I like about RStudio is like this commuting 3 was was what I read from the SAS file. It has a viewer, and you can actually look at it like you would look at like in SAS. And you can also do some sorting here. I don't think it persists. Like when you close out the session, it goes away. So you actually want to do like any ordering of your data you want to do within the console. But if you just want to look at something like, say, what's the max value, you can do some filtering. So this is, you can look at this that section has a number of different tabs. There's a file explorer, so you can look at what some of the files are. This is where plots show up. You can see what packages you have. You can turn them on or off here. You can open up PDF files for them, the documentation. So it's a lot easier. Also, you've got some things up here that are really helpful. And if you want to do some of those R Markdown files, you can also do them here. In fact, this is the slides I've been showing. This is actually the file with the code, and so this is this is just text, right? So these are my headings, these are my bullet points. And then there's some of the code, and when I run it, so when I run it, it just recreates that slideshow I was telling you about. If there's something wrong, it won't bring that up, it'll crash, so.
So our markdown is downloaded and then you save it inside
Our Markdown, when you get RStudio, a lot of our Markdown already comes with comes as part of RStudio. I think there are some extensions you can get, but yeah, like this what I did, this version I think I just got straight from RStudio. It just comes as part of it. So when you open up a new file, you can say I want this to be a script, or I want this to be a Markdown file. So, and they've even gone far. There's even something called Notebooks, which is similar to that, which I think a lot of people find easier to use. I'm not quite sure what the differences are. I haven't explored that too much, but yeah. So that's another advantage to RStudio is you get that you get those packages that allow you to do R Markdown. Pardon?
Can you share the R code?
Yeah, I'll share. Yeah, I can also send the slides and the data so that if you have the slides and data, you can just rerun all this. And which is, in some cases, I've showed the code. In some cases, I haven't showed the code. But with this file, if you share this file with somebody, the code is there whether I show it or not. Yeah. If people want to email me, or if we can, I don't know, how do we?
Peter, all the presentations from research are posted online.
Yeah, we post the presentations usually in PDF format on the Yahoo group. So any file that send us, we can say will be posted to the Yahoo group.
And yeah, if you want to, I'll leave.
Yeah.
Series of weather business criteria if people want to travel.
And the Twin Cities Research Group has a Yahoo site, a group site. So if you get your email, like getting email from us announcing the monthly event, I can send you out the link to the presentation. Otherwise, you need to go to Yahoo and sign up on a listserv, which does require you to have a Yahoo email.
There is a way to avoid that.
Oh, okay, well, good.
Then if people are really interested and start using it, I've often, one of my aspirations is to have a research. Well, there are some R user groups. A lot of times it's big data folks, people trying to write, machine learning to figure out if something is spam or not. I'd be interested if there's sort of like to have an R user group that's maybe government researchers or social science researchers, which are more sort of it's a great group, and I go all the time and I learn lots of stuff. Some of the stuff here I wouldn't know about without going, but it's often big data questions and recommender systems and stuff like that. So it'd be interesting to see if there would be like a group for people that focus on some of the questions I think that a lot of people here are interested in. So. Yes, it's good to have a support group. Well, thank you, everyone.
Yeah. Thank you, Dennis. And we're going to go for a little bit longer. We have switched our time now. Every meeting will start at noon. It's 12:30 if you're doing the task. But if you have more questions for Dennis, I think you can stay around a little longer.
Yes.
His card is here. We'll try to send out that link to everyone. And one person who has helped us a lot here as weather research is Peter. Peter at Massachusetts Peter has been kind of the guru that has helped us get everything set up, all the audio visual, has kept us on time and a great resource. Fortunately for Peter, unfortunately for us, he's going to Chicago to go to school. So this is his last week. So if we could all give Peter a in September, we're going to be having categories of how to classify different categories of race, a presentation that's going to be at our next in October, or, the policy analysts have a program, so we would not be having a meeting in October, but we are gonna have a social event, so if you wanna volunteer for the social event, please, come and talk to me. And I think, yeah, okay, thank you very much. We have stayed on time, and we're about 30 seconds over. So, thanks for coming.